Can you hear me now?
Yes, ma'am.
Okay. Can you confirm if you're able to see the screens, ma'am?
Yes, ma'am.
Great. Thank you so much for the warm welcome and the kind words. Pleasure connecting with all of you, and I'm so excited to meet with all of you in a situation like this. And I hope you're all staying safe. Kausalya, ma'am, thank you so much for the invite. I know we share the same names. It's even more exciting. Now, when you're calling names over here, I too get confused. Are you addressing me or you addressing the ma'am? But it's interesting. All right. So the topic for discussion today is data science, and as a practitioner, I'm going to take you through where this world of data science is heading towards, what are the opportunities that are out there, and talking about how do you kickstart your journey into data science if you're a newbie, you're trying to kind of get your heads around. So I'm going to put across certain pointers over here. Okay. So with that said, ma'am, can you just confirm if you're able to hear me clearly? All
Yes,
okay?
ma'am.
Great. Thank you. So here's a quick disclaimer. I know we are having a very kind of a remote session over here. Um, so it's going to be difficult with respect to kind of having a very engaging aspect to kind of gauge your attendance and all of that. But trust me, I'll take this 1 hour to make it as interesting and productive as possible. And I'll also leave across my handles towards the end. And if there are any specific queries that you have, we'll open it up for question answer. And if it is anything apart from that you want to kind of interact as well, please feel free to reach me out. With that said, let's quickly delve into the topic. So here's a little kind of a complete explanation of different milestones, key milestone in the field of data science. So a timeline representing the milestone. We are right now here in 2020. So I've highlighted over here. So we know where the hype is about, right? There's a lot of buzz around artificial intelligence, machine learning, the field of data science, the way it is kind of looked at in the market, the different set of courses that are coming across, the way people are flocking towards it and kind of moving towards that direction, right? Now, with that said, from there's been a lot of evolution from day one, and now as every technology has its peak, here we are heading towards the peak of data science. So there's a lot of new platforms, processes that are kind of coming across, and now, from artificial intelligence and machine learning, we are looking at a blend of these two, calling as machine intelligence. And there's also decision intelligence that we are moving across. So there's a lot of growth that we are looking in this space. Now, if you kind of go back a little bit, 2014, if you look, an interesting incident happened, which is Google's AlphaGo, an AI solution. DeepMind was their AI solution that they had, and that actually bet the Go world champion Lee Sedol. We'll come into why this event is significant. Yes, it is a game, and we're looking at a board game, and a machine was able to kind of um, beat the world champion. And it's not the first time that has happened in the history. Probably about 17 years ago in 1997, a similar incident happened, and it was by IBM's Deep Blue machine. What it did was it bet the World Chess Championship, Gary Kasparov, in a six-game match. So if you look at these two significant incidents, right, that is also a game, this is also a game. So what is a big difference? A machine is able to kind of beat human is what you might be looking at. But if you look at the way it is kind of moving towards or evolved into, it gives you some more fascination into it. Say for example, if you're looking at the deep mind machine that in 1997 that we were kind of celebrating, it was more with respect to the machine was trained by chess experts or grandmasters to play it efficiently. Okay, so as we know in chess, it is always about who makes the future moves better, who thinks about more moves into the future. That's what we think about chess as a strategic game, right? Now when you compare a game like chess with go is much more complex, and it is complex enough that it is actually impossible to run through every possible moves. So what differentiates between a expert and a beginner in go is the level of intuition that you can think about in making the sense of the game, the intuition sense of the game. So when you're significantly looking at these two incidents, right? The first one was the system being trained and to kind of give out the results based on the training. But here in Go, the system trained itself and it evolved from it, and that makes a huge difference and it puts a
Ma'am,
stamp.
ma'am, excuse me, ma'am.
Yes, ma'am. Can you hear me, ma'am? Hello?
Ma'am, the screens are not visible, ma'am.
Ma'am, the screens is not visible,
Okay,
ma'am.
just give me a minute. Let me quickly share again.
Okay, ma'am.
I see another person is actually okay. I didn't
Is
realize that.
yes,
Divya Kant.
we can't farmer.
Yes. Can you stop sharing?
Divya Kant.
Okay, so from the beginning, my screen was not visible, is it?
Yes, ma'am.
Okay. You could have probably prompted me a little earlier. Not a problem. Is it possible to stop sharing from the host side? Can I go ahead and share,
Yes,
ma'am?
ma'am. Yes, yes, ma'am.
Okay. Can you see the screens now?
Yes, ma'am.
Can I proceed, ma'am?
Yes, ma'am.
Okay, so I was just giving a background on the data science timeline. So we were talking about where we are right now and the difference between the evolution between what happened in 1997 to 2014. So we're looking at how deep blue versus deep mind, what was the evolution that has happened. Now, in this standpoint, apart from this, so this incident predominantly puts a point to say that how machines can now imitate the sense of intuition, which is actually the only thing which is very special about human intelligence, right? And now, if machines are able to kind of emulate that intelligence, to what level we can move forward is what this incident puts a point on. So that's one significant milestone. And the other significant milestone is with respect to, you would have heard a lot or read a lot about data scientists being kind of put across as the sexiest job of 21st century. And the term was actually coined in 2006 by an Indian DJ Patil. So this is the very high level timeline what we have on the field, in the field of data science. Now, if you move a little bit further, let's take a look at what the global market is right now. So it is predicted and projected to reach of about 512 billion by 2026, which is about half a trillion US dollars. Now, if you look at the price of it and the way that it is projecting towards from 2008 to 2026, this is a tremendous amount that we are looking at. So this obviously would create a huge job market and a lot of business around this stream of data science, because now you're looking at every industry, every organization as a part of the digital transformation. Analytics is one of their stream that they're looking at. And also with respect to any new products that you're kind of looking at that is being launched, you look at data science and artificial intelligence or machine learning being embedded into their solutions, right? In that aspect, if you're looking, this is a pretty huge market that we are kind of looking into. If you have a question of, oh, look at the uncertain, ambiguous, or a very pandemic crisis like the COVID that has struck all of us, right? In this situation, every organization is looking at cost cutting. They are looking at different ways that they can kind of put all some of the projects, they put it on shelf. They are not going to kind of look into any more operational um, improvements within the immediate future. What ways are they handling? There's a lot of COVID impact that is hitting all of us, right? In such a scenario, will this numbers change? If that is your question, let me be honest, yes, it might change, but it is not going to go very drastically down, because analytic initiatives and data science initiatives are always looked at more strategic. Organizations may put their operational initiatives to a back burner, but not their strategic initiatives. So, in that sense, these numbers will definitely kind of keep their place, or it might increase as you're seeing a lot of adoption into digital streams right now. Now, we talk a lot about data. The field of data science is entirely about processes and tools to harness data and look into how you can decipher insights out of data. What can you make out of data? Now, let's take a step back and look into where did this all data flow from, right? Now, all of us have smartphones and we are technically connected with everyone in the world in a way or other, right? They call us 6 degrees of separation between one person and another person. Now the degrees of separations are coming down. Now if you look at this aspect where we are right now, it's something fascinating to look into what we used to have a look into our Hollywood movies and all of it, where every actions can be predicted, every aspect can be tracked and all of it. Right now we are being tracked like that. So we leave a digital trail no matter what we are doing, right? Be it with respect to browsing online. So based on your browsing, whatever articles or news that you looked into, or suppose say I was trying to book a flight ticket and I was trying to kind of make a trip to Delhi. If I looked at what are all the flights to Delhi, then when I move to the next page, when after sometimes when I log in, I get recommendation kind of inputs on what are all the hotels that are available in Delhi. Have you made this purchase? If not, they try to influence us in some way, right? Now, be it shopping in a brick and mortar store with your credit card, or be it with respect to sending an email, sharing your post in social media, be it with respect to a text post or with respect to a kind of images or whatever that you want to put across, right? Or reading, consuming news online, or just walking in the street with your phone in your hand. So it has the location tracker, it has the information, some of the apps which can even track you even if you're not open. You see all scary things that are around. So in some aspect, every action of ours is tracked. And it's not just the activity, even our inactivities generate data. Example, if I try to book a cab from my home to the airport and I see a fare being listed and it is not the usual fare, it looks like little higher, and they call the surcharge fee increase in the due to the peak time, there is an increase, right? Now if it is even with that I see an increase, what would I immediately do is I would look into Ola. I have choices as a user, I have choices. So when I look into that and then I book a cab and I move forward, so Uber will still be able to track that I tried to book a particular cab, I was unsuccessful in the booking, and then I am still on the move right now. They don't know I'm using Ola, but they know that my suddenly my location is drastically changing, which gives an indication that I'm on the move. So immediately they send a message asking, you tried to book, did you face any inconvenience in booking? How can I help you? So there is a service aspect that they put into place, right? And if I say that, yes, I was not very happy with the price that was quoted. And what if after a week I get a voucher, a gift voucher talking about, here's a discount for 300 rupees. So it's not just the activity we are talking about, our inactivities are also being tracked, and organizations, product companies, service companies are trying to kind of tap into this, look into the behavioral aspect of the consumers and try to make influence decisions. Now, in all of this, data science plays a huge role. So when you're talking about data, it's not just about numerical data. We understand, right? The big data, the world of big data itself is about velocity, variety, be it with respect to the different V's that we are talking in terms of how much of different kinds of data and in the speed at which it comes, we can harness it and take it to the next level. If you just recollect, right, 2 3 years back, everybody was talking about big data. Now nobody talks about big data. It's not that big data is not of that significant importance now. It's just that big data has become normal terms right now. So it's moved from the peak into the mainstream, that it is mandate to have a big data solution in some form or other. Now the other aspect is to look into the data talks about an intent, what it has. Say, for example, I recently, with all this crisis situation, and everybody is kind of moving towards this online, right? Business, schools, public services, everything is moved online. And with staying indoors, a lot of demand for online learning, fitness, online fitness. Sounds crazy, right? Even you have fitness classes online, be it with respect to core fit or yoga, or be it with respect to Zumba classes, even that is held online. And there is also these OTT platforms, the famous ones, right? The ones like Netflix, Amazon Primes of the world, Woot, Hotstar, and all of it. Now, suppose, say, you watch a movie in Netflix. You pick a particular genre. Say, I picked something like Money Heist, Designated Survivors. This is something not during the COVID I'm watching. I've been watching for some days now. So if I watched Money Heist, Designated Survivors, Patriot Act, and four more shots, I get a recommendation on some things, some of the shows like Working Moms, which has no correlation with what I've already watched. Because if you're looking at the genre of Money Heist, Designated Survivors, Narcos, that's a different genre of web series. Patriot Act is a completely different genre of web series, and Four More Shots is a totally a different genre of web series. But the recommendation that comes across to me is Working Moms, and which is the one of the best, most funniest series that I've enjoyed watching. So in a way that it including me, right? There are 75 percentage of users, they watch Netflix based on the recommendation that's coming across. So look at how much they can influence, to what level they can influence, and it actually talks about the behavior. It talks about how the content has to be served to a user in a collaborative way, and what basis are they collaborating. It's to look into what the common interest of same kind of profile of users are out there, and bring out those and put it across to the users. And you even get recommendations, right? To what level of accuracy the recommendations are accurate for you. Like based on what you watched, it says 98 percentage of accuracy it brings out, right? So this is the all of this behind the scenes. Data science, the tools and the process are being used to whip it into shape and get it into a form to ensure we make in this more of insightful decisions. Now, if you look at it, we, like I was telling, we have a lot of choice as a user, be it with respect to a travel. If I have to book a cab, I have options like Ola, Uber. If I have to order food online, I have Swiggy, Zomato's, or Uber Eats. If I have to shop online, I have Flipkart, Amazon. There are so many choices. So it is very, very. Ma'am, can you hear me? Did I lose presenting rights?
Maripan sir, உங்களோட இது மியூட் பண்ணிக்கோங்க சார். It's noisy.
Ma'am,
Again, someone is sharing.
I think someone else started presenting. Can you revoke the presenting rights?
Yes, ma'am. Ma'am, now you can, ma'am.
Okay, ma'am. 1 second. Okay, can you please confirm if you're able to see my screen?
Yes, ma'am.
Okay. So we were talking about the choices a user have, right? Now there is also about anytime, everywhere, and anything we are connected in a way or other because of the connected devices that we have, like the mobile phones, and all the apps are available. We have the access to be channel. There are multiple channels that we can access to information as well, right? While mobile being one of it, there are other channels as well. Now these are some of the things which are kind of contributing to the data accumulation that we have. Apart from telling that yes, cloud is affordable, compute storage network is very, very cheap, so everybody is kind of leveraging that. Now the way or aspect that everybody can afford to 3G 4G, now we are looking for 5G as well, right? So how we can utilize the power of internet, and we are accumulating this data volume. Now as we are accumulating, what organizations are looking at is, with all the volume of data that we have, they have access to how they can innovate, how they can accelerate and use this analytics and data science as a stream, or leverage it to take it to the next level. That's what organizations are looking at. So it's basically to accelerate and complement what the business is trying to solve, or the business problem that they're trying to solve, and come up with innovative solutions. And when you're talking about innovative solutions, we're talking about a data driven innovation rather than just talking about facts, just talking about guesstimates, guesses and estimates. We're looking at coming up with more data driven decisions, so you can, the innovations are also kind of complete. Now, let's take a look at what is out there with respect to the job market, or how is it looking at. We talked about in how data scientists, the role of data scientist was dubbed as a sexiest job of 21st century. The reason being, it's a blend of multiple streams, so it's a unique skill that they are looking at. So there's a huge demand in the market, and as always, the supply is very less. So while the demand is there and the supply is less, there is enough competition that is there, but still we are not able to fill in certain requirements specifically for very innovative solutions and all of it. Even in the situation of COVID, if you just open up Naukri and all the job portals, you would see a lot of requirements coming up for data science, data architects, a lot of these streams around ML, data engineers, and all of that. Because like I said, it's strategic initiatives that organizations will start focusing on when they hit the crisis, when they hit the rock, rock bottom. In that aspect, right, data science is something like an anchor that they want to kind of hold into. So in that aspect, if you're looking at getting into the stream and mastering this, or you have a fascination towards it, I'll probably say this is the right time to learn, because it has reached a level, I wouldn't say a saturated level, but it's still an evolving field. But definitely it has a kind of a very standard that it is reaching towards. So you have courses, materials, many have an idea, and mainstream, you're seeing a lot of it being applicable in the market as well, right? So in a way, we are all consumers of data science solution, like the ones in Ola, or be it with respect to Amazon, the e-commerce sites, or be it with respect to OTT platforms. Everywhere we are trying to kind of influence, or the CRM applications are all connected in a way. Today we are seeing a lot of analysis or ways in which you can keep customers engaged, influenced, and in all of this, underlying data science will play. So across the streams, you will see a lot of job requirements that's coming across. And in few slides, I'll explain through what are all the different job requirements that are there. In a nutshell, if you're looking at it, so it is a process, it is a set of tools which will help you in deriving decisions and actions. So with all the data that we talked about, the humongous volume of data, organizations are trying to kind of bring in insights. What insights? There's a huge difference between raw data and insights, right? And so what is that you can draw patterns on, forecast on, bring in valuable information out of it? That's what you're looking at. And in a way, to make actions, in a way to make corrective actions or actions that can increase the operational efficiency, bring in cost, or increase your profit. That's what organizations are looking at. So this is a field, this is a stream that we are looking at, data science. Now, the famous one when you're talking about data science is our famous Venn diagram, the blend of multiple disciplinaries and stuff, right? Now, while that is true, you see that it is not just one aspect that we need to kind of be a master at. We have this, did I lose connections again? Did I lose the presenting, ma'am?
No, ma'am.
Is it still
It's
visible, my
visible,
screen?
ma'am.
Okay. Okay, so let me know when my screen is not visible. I don't know how it's somebody can take the control, but let me know when you're not able to see the screens. Okay.
Sure,
So
ma'am.
we are
Sure, ma'am.
talking about data science, and we're talking about it's a blend of three different streams. Computer science, which always used to be with respect to software development, application development, integrations, or analytics, and all of it. Now, domain aspect as well, domain knowledge is also needed. If you have to solution something for the banks, you need to understand how finance works. If you need to solution something for the life science industry, you need to understand how pharmacology works, or be it with respect to how different subsets of that work. So any particular solutions that you're trying to bring out, a domain knowledge will be in value add and give you more understanding. So that is needed. Now, what is special here with data science is since it's a scientific process, there's a lot of math and stats that is involved into it, which helps in kind researches. It helps in more of machine learning. Machine learning, again, this is fancy, but it's completely based upon statistics, probability, inferential calculus, and also with respect to hypothesis testings, right? A/B testing and stuff. So a blend of all this put together is what data science is. Now, if you have to be a data scientist, you should be comfortable in all of this. Like they say, jack of all trades, master of none. We have to rephrase that to say jack of all trades and master of some. You have to have an understanding of some of these streams over here. If you have to be a specialist, yes, you need a very good understanding of all of this put together. But is data scientist the only role in this field of data science? Absolutely not. There are multiple roles that are out there. There is a data engineer, there is an AI ninja, there is a data analyst, there is a software engineering roles are also available. So there are a lot of other roles that are also available. So let's look into them, right? I've bucketed them based upon their tracks. Like if it's from the technology track, it could be a data engineer, data architect, software engineer. From the statistics track, if you're looking, a data scientist, data analyst, ML engineer, and AI ninja. But the level of proficiency of them would differ. A data scientist would have more level of proficiency compared to a ML engineer and a data analyst. Data analyst would predominantly work in the visualization tools like Tableau, Microsoft, Power BI, and stuff. Now, as they move into the business, it moves into more of managerial aspect, right? Now, a product manager now who's trying to kind of bring in a data-driven product, or be it with respect to putting in an analytic strategy, should know a blend of these together. So there should be an overlap that you're looking at. So these are the different roles that are out there. So like I said, each of these roles have different level of skills that is required. Not all skills are common across the board. There are certain skills some needs to be specialized at, and certain skills some, even if they have a shallow understanding, it is okay at this point. Now, this slide I specifically wanted to highlight to give you the aspect of what is the market out there, specifically with respect to the salary packages. And what you see is a rough representation and taken from Glassdoor and Analytic India magazines, online magazines. And as you see, typically with respect to the normal roles to this, there is a 40% higher hike involved in the salary packages or brackets that you're seeing over here. So it's fascinating, it's exciting, but you have to be a master to kind of blend into this roles and to kind of be a specialist in what you want to kind of move towards. Now, while we're talking about data science, Many say that it is this predictive and prescriptive flavor of analytics, which totally condense it into a data science problem. But data science is far more beyond that. So you can't just bucket these two alone. There are a lot more of approaches, a lot more of problem statements that we can also kind of look into in solving business problems out there. This is a very interesting one, right? The customers who bought this also bought this item, what we see in Amazon or Flipkart when you're trying to buy online. And here is something like forecasting or predicting what would be the price of a flight when you book now versus when you have booked it 3-4 months before. So these kinds of predictions and prescriptions can also kind of fall into the bucket. Now, each of this that you're seeing over here are different approaches of analytics: business intelligence, diagnostic, predictive, prescriptive. What you see is the problem statements that they try to solve is different. What the result of that is different. One is tracking of KPI, one is patterns, the other one is forecasting and is about recommendation. So let's look into it. So now each of these capabilities or approaches that you have, right, have a specific set of intelligence. Like a descriptive flavor of analytics would help in tracking KPIs. It is the nature of it is deterministic and it is operational problem solving that you're trying to do. Simple example is in sales analysis, if you're looking, which is your topmost revenue generating product line or item last year. You don't need fancy data scientist or specialist to come and do all this. This is pretty simple. This is business intelligence solution. So if you have the data in the system with the history information, you should be able to do that. Now, if you twist the question a little bit more on a scenario based, how would this problem be solved? Right? So that is what if analysis, tracking of the KPIs in a scenario. So what we're trying to do is from deterministic, from operational, it moves to strategic initiatives. Now, based on the planning at a business and product level, which product line or item is likely to show increased profitability against last year? So in a scenario, you're trying to kind of gauge the KPIs, gauge the metrics. So this is different from the previous question. So the type of question differs. Similarly, if you look at predictive, discovery, and prescriptive flavor of analysis, the type of question differs. So the level of intensity of problem solving increases. From operational, we move to strategic, innovative. From deterministic, we become probabilistic. From tracking of KPI, we give recommendations on actions or behavior. We are looking at discovery of unknowns. So it's a very interesting way that what kind of problems can be solved and how it moves towards. So as you gradually move from analytic business intelligence to analytics to data science problems, it's a very fascinating aspect where there's no limit on to what level we can go and how we can kind of move forward. The only thing is we'll have to follow ethics in moving forward, and also with respect to follow the approaches properly, and not just because to increase accuracy, if you put in incorrect data, noisy data in, and then you're not going to kind of come out with what the results are going to be. The end result to be is to make informed decision, right? Data driven decisions. So if we have to kind of have that proper, then we need to identify the right data sets, we need to identify the way we need to do things. So here's a approach, a representative approach of how the different processes that are involved in solving a data science problem. Okay, suppose say I'm kind of doing an analysis on the different drugs that I am analyzing for finding a vaccine for COVID. Okay, so if this is the problem statement that is out there for me, and I have to come up with a pattern to talk about which particular drug medicine is giving you a positive result in controlling the virus, immunizing the virus. If this is a problem statement, I need to understand the domain of life science really well. I can't just jump into it without having any idea about it. I need to understand the different patterns. I need to have a lot more of research aspect into it, and that is where a functional analyst role from the respective domain will help. And if I do not have enough of that data, the functional expert from the respective domains should be as a part of the team. So in a team building, we will be looking at them. Okay, that will be the first one. So I should be framing the problem. Nobody is going to say, do put this algorithm, linear regression algorithm, and give me the predictions of it. Nobody's going to give us any problem statement like that. They're going to talk about what is their pain point, and they're going to ask us a solution for it. That's how they're going to do it, right? Now, if you have to kind of take that into your mind and process it as a practitioner, as a expert in the system, you should be able to understand what kind of problems can be solved by what kind of techniques. So that's what this framework will help us out in. So the next step is with respect to collecting the raw data. Now, if I'm talking about the drug trials that we just spoke about for finding a vaccine or analyzing the different combinations or patterns that is available right now, how it is behaving and all of it, I need n number of data and not just data in one skewed aspect. I can't just take a data which is, I need volume of data, I need a variety of data, and also from a more of a diversified data pool I need. So I know that this works for every condition and not just for one condition. And I should also look at the macro factors, the climatic conditions, the ethnicity, and all of these things also has to be factored in when we kind of bring in the solutions for it. Now, the other thing is about processing the data. Once I collect the data, I have to process it, which is, I can't just use the raw data that comes out of any system and start moving with making business insights. I need to process it. It's just similar to how we do our prepare our food at home, right? When the moment you buy all the ingredients, it's not that you can serve it on the table and call it a biryani or a delicious food. You have to prepare the food. So you need to have all the ingredients in place, which is our data. You need to have all the tools in place, which is like our stove, our knife, our tools, and all of that, the tools, which is typically the tools what you see in the business scenario as well. And for data management, you need tools. For processing of data, you need tools. For visualization, you need tools. So these things also need to be kind of available. Now, once we do that, that is about processing, harnessing, which is cleansing, processing, harnessing, wrangling of data. The next one is with respect to exploring data. So once you have all that ready, you should be in a position to extract the data information out of it. It's called feature engineering. So where we interpret what the data is talking, and then we take it forward with respect to modeling the data. In this phase, step number 5, we have to look into what predictive models should we put into place. If I'm talking about a regression, there are multiple regression algorithms that are out there. I need to know what regression algorithm is the most recommended one to go forward with this problem statement. So an expert should be able to kind of tell that across. And then there is always refinement, always continuous improvement that is needed in this process. It's not that one step you get everything in place. So there's always continuous improvement that we need to do. So you have to go back to the previous steps and do as well. The final step is communicating the results. Once you have done the analysis, once you have all the details that is required for it, now what we need to do is communicate the results, interpret the results in a way that it is solving or trying to add on to the problem statement that you're trying to solve, and give you the evidences for that, whether it is in the positive way or in the negative way, or at least you get the judgment of this works, this does not works, right? So the framing of problem, what you have, the step number 6 should be addressing to the problems that you have already kind of put across. So it should be addressing the pain points. That's what we're looking at in a process. Now, while we talked about this, each of this process has a specific skill that is required. So, for example, if I'm the first one, framing of problem, like I said, we need domain knowledge. We need the more of what we are trying to solve. We need to understand the strategy, data strategy. We need to know how to measure the analytic success. So that is something on the framing of problems. But when you're collecting of data, this particular step, it's about data management. It's about retrieving of data. It's about storing data in a distributed format. So those are that need separate skills. Then it is about processing the data. So when you're talking about processing, you have these techniques, ETL tools. So even tools like programming tools like Python can also be used for ETL operations. Now, this wrangling, cleansing, processing of data, there are separate skills that is needed. Listed here are few of them, not all of them. Okay. So similarly, for exploring of data and for machine learning, for analysis, you need to understand what they are. With respect to the statistical understanding of it, like what libraries to put in place to do this particular feature engineering aspect, or be it with respect to machine learning, what problem is it? Is it a regression? Is it a classification? Is it a clustering kind of problem? And accordingly, you should be able to move forward. Now, communicating results needs a lot of understanding with respect to visualization techniques. A business user will not understand just what the raw data talks about. If you're just talking in terms of raw data, it does not make any sense to the business user. You should be able to tell a story out of it. So story narration should be there. So for this we need a lot of in ways in which we can represent the data visually, graphs, metrics in different graphs. You need to know when to use a pie chart versus when to use a scatter plot, when to use a histogram versus when to use a line chart, a combo chart, how to kind of put things into place. We are very used to seeing all these charts in newspapers, especially during like IPL season and all of that, right? And even with COVID, we have all these statistics coming across. What is the increase in percentage compared to previous day? How much is it compared to another country? We have so many analysis that is being put across. So it is because the visual representation stays in our mind longer. We are able to interpret it better. So in that aspect, a lot of story narration, visual storytelling is what we need to kind of master at. Now, if you go back to the previous slide on what are all the roles that we looked at, right? There were multiple roles that we are talking about. All of these roles will have one or a combination of these skills put together. Say a business analyst will be too good in communicating the results, and they will also be in some way involved in framing of the problems as well. A data engineer will be too good in collecting and processing of data. A ML engineer will be too good with respect to performing in-depth analysis and exploring data. So each and every role has specific skill that is needed. So if you have to start your journey into data science, you have to understand that data scientist is not the only role. There are other roles as well. Pick your role and accordingly skill yourself. Okay. Now, this is a representation of what are all the different applications of data science. And you would have seen a lot about this in different forms and shapes, right from autonomous self-driving cars to sentiment analysis to trending news that's coming up, and be it with respect to discount percentages or cross-selling and upselling in marketing kind of scenarios. You keep getting calls from the bank talking about you already have a personal loan, do you want to top up that personal loan? And also with respect to here is a discount, would you want to go forward with the discount? And then they also talk about so they look at conversions of that. The bank has a lot of products. Banking, apart from financial transaction, we're also looking at a lot of products that they're offering, and they're trying to gauge how much a person will, a user or their consumer will take those services forward. Right now, if you're looking at cases like the big billion day in the e-commerce sites like Amazon and the Flipkarts, we have additional discounts coming up. If you have a HDFC card, you have additional 10% discount. If you have a ICICI card, you have additional 15% discount. And then they look into, based on the conversions of that, they look into how much of influenced purchases have happened like this club memberships. if you have a Westside Club membership, all your birthdays, you will get an additional 20% discount. That entire month, you'll get an additional 20% discount. So these kind of influenced behavioral analysis and all that happens, right? Now we all are across every industry right now. If you look at it, if you just pause, close your eyes and look at it, in some way or other, you have a lot of algorithms around you influencing every action of yours. Algorithmic decision making is what they call this. It is very, very interesting to see. If you get a chance to read this book called Homo Deus by the renowned historian Yuval Harari, look into the specific chapter of data revolution. The author beautifully explains about how algorithms are controlling our life, even unknowing to us. According to his portrayal, he talks about a concept of dataism. Very interesting. He says that for any data scientist or people who are experts in this, right, for them, uh, Beethoven's Fifth Symphony, a stock exchange bubble, or a flu virus like the COVID kind of case, right, are all just three patterns of data flow. Nothing else. All these three, though these three are totally different, these are just data patterns. They can be analyzed and processed using the same tools and techniques. There's not additional tools and techniques that is needed. So this idea is just simply attractive, and every organization is looking at how you can make or capitalize on this. Now, if you, it is even not startling to see that there is a religion that treats AI as God and advocates for algorithm to rule the world. We're talking about religious fights and all of this, and all of in that ways we are moving forward. But look at this, right? Just Google it out. There is a religion for AI, and they say that the algorithms should rule the worlds. It's an interesting aspect, so different perception that's going around. But you see that in every way algorithms are controlling us, and in some form or other, all of this we are consuming, we are voluntarily giving our information, or we are controlled in a way to make decisions, influence decisions. Okay, so here's a quick roadmap that I want to talk about. How are we doing with respect to time? Yes, another 15 minutes to go. All right, so we talked about what is the field of data science, why is it important to jump into the bandwagon, what are all the skills that are required. Now we'll talk about how do you get started. Okay, so I've broken it down into 5 simple steps over here, and some of them are interconnected, so we'll look into it quickly. First thing is you need to learn to code. Even if you're not a very fancy or fascinated about coding, that's fine. I've also not been a very good, I've not got very deep interest into coding while still at least like 4 or 5 years ago. But I think it's okay. And today, these programming languages like Python, scripting languages like R and all are even more sophisticated. And the moment you start playing around with data, it's fascination, it becomes addiction. So I would suggest please learn to code. Start with Python. If you've already started with R, no harm in that. Please go ahead. But if you're just going to start with Python. It's far more advanced. The UI is even more flexible for you to play around, so it'll be a good start. And apart from that, you need to learn basic math. If you want to be an expert, go for deeper. Linear algebra, probability, statistics, inferential calculus. You need to kind of look into all of these. Multivariate analysis, univariate analysis. You need to look into all of these. So, and also get an introduction about SQL for data science. You need to kind of look into how to analyze data, query data, which is at a very distributed environment. So you have to understand that aspect as well. And once you start to code, get into forums. There are forums for Python, there are forums for R. Get into forums, look into how people are solving it. Pick ideas from them. It's okay. It's not rocket science and stuff. It's just simple science. So what you need to do is ensure that you have that interest built. And like I said, as you get your hands soiled into data, real data, it's a lot more fun. You'll keep gripping on that. The next thing is to learn with data. Again, reiterating, get the live data sets. And there are a lot of synthetic data sets that are available for access as well. The most accessible ones are UCI machine lab repository. And there is also, if you just go into data.gov.in, this is our government data sets will be available for you to do your analysis, come out with beautiful insights. And there are also US government data sets are also available. We can play around with that. And generic data sets in Kaggle, GitHub, you will find a lot of them. So you can soil your hands, and it's about practice. It's about practice and coming up with what insights. And we are not doing it for the first time. There would be n thousands of people who have already solved that problem, and you can look at it in a different angle. Look into how analytically you can do things better. The next one is to start with applied ML. Look into what libraries you need to kind of have, and also into what are all the problem statements that are out there and what kind of algorithms can solve it. Regressions, classification, clustering, anomalies, right? What kind of algorithms are there for each one of these? This is just applied ML. And then you can get into another level. Once you get comfortable in this, ensuring that you can do error measurements, cross validations, and all of that, then you can get into the next level of getting your hands into deep learning and stuff. So, but get into one at a time, right? So there should be a progressive advancement into this. The next one is about more application and more theory. This is not a stream where you can say, I know everything. This is an evolving stream. There is continuous learning. Today we have techniques for auto ML. You don't even need to know how to script algorithms. There are applications which can help you to do that. So if that is the case, then what is the next thing that you need to learn? You need to quickly get a grip of that. So what will help you is you need to be connected with right set of people. You need to be connected with practitioners, data science practitioners, and also you have to look into who are all the experts. Follow them in social media, not to look into how their family is and all of that, but you should be professionally connected with them to understand what kind of work are they doing, what kind of contribution there are that they're doing to the organization. If you want to be one of them or look like one of them or do better than them, you need to understand what are they doing now, so you can better yourself, right? So you need to connect, network. If you're getting into a little more comfortable level, you can start blogging. Even if you're not, even if you start blogging, you will start correcting or putting in even more effort, ensuring that the content should be clear and simplify it and put it across. So even blogging can help. Go to meetups that are local in your place. Now, at least with the lockdown and stuff, please don't go search for physical meetups which are happening in locality. It's not actually, but we have a lot of virtual meetups that's happening. Connect in them. There are Slack groups, there are Telegram groups that are available. Connect in them and exchange ideas. Listen, be a passive listener for now. Once you get more comfortable in the streams, you understand what they're talking about, then you can be an active contributor as well. So that is also something that you can kind of get started with. The last one is about building your profile. This is very essential. While you did all of this, now you have to portray all of this in your resume. You have to highlight them. It's about how advertisements are being put across in commercial advertisements come across, right? You need to put across your profile, highlighting your work. I'm not telling do a lot fancy exaggeration and do you have, if you have to put something in your profile, you need to know in and out of it. So if you have to put across a data science profile, you need to know what are all the skills that is needed and master those skills. So the first homework, what I would suggest is go to Naukri, go to all these job portals, look for data science roles, data science head, data scientist, junior data scientist. Look at what are all the skills that they are requesting for, responsibilities, roles and responsibility. Copy that into a screen. Consolidate from 5, 6 roles like this. Then start putting check marks. You will see a common pattern. You will see that they will require for a programming language or data management skills or visualization tools and all of it. Then you know where to get started with. So that's one approach that I would suggest for you to kind of start building. And you need to know how to highlight it. GitHubs, having Kaggle, participating in Kaggles will all contribute. So document all your work. Not it's not good to kind of just have everything theoretically figure out. Practically, you need to know how to apply it. So if there is internship available at this point of time, at least for the first 5 years of your career, all that you need to focus is to look into how much of knowledge you can gain. Don't look at what package of salary you will get into. So if there is an organization which has a scope where they're doing data science, jump into it. Get head over heels to get an opportunity, internship opportunities, utilize it as much as possible. Be accountable for whatever deliverables that is there. Figure out, break your head, get the solution out there. Okay, so there's a lot of aspect that we need to, all of these are in some way connected to each other. So if you go to GitHubs, go to Kaggle, look at who are all the grandmasters, you will know what kind of background they're coming with, what kind of problems they're solving. You will get a lot more of ideas. So this is just the beginning, the first step probably that I'm putting across, but you can explore a lot more into it. Okay, so with that said, I think we spoke about all of this. The industry is looking for, like I said, they're not going to give you a problem statement like, okay, put in linear regression, get a 75% of accuracy and above solution for this problem. Nobody is going to tell us like that. So we need to understand. We need to understand what pain points and work accordingly. And we should come up with more of opportunities, ideas with data. Everything should tie back with data and use this data and move forward. Look at what models we can create, and there's a lot of continuous learning and upskilling that we need to do to move forward. Okay, so the what we have seen so far, or what the world has seen so far, is just with the tip of the iceberg. With the advancement that we are having every day, I would say probably we have not even touched the surface of it, right? Now, this is so much deep to learn, and I'm also learning, and would urge you guys also to kind of learn and move. Let's bring in a collaborative platform, collaborative learning environment. There are so many forums. So let's get engaged, look into what new advancements are coming across and how we need to kind of move, learn, get the passion of learning into the stream if you've decided this is going to be your stream. So as every technology that has changed the world with the right strategy, time and space, I'm very certain data science is also kind of changing right now. Not kind of, it's already changing right now. And if we have to jump into this bandwagon, I would re-quote Alvin Toffler to learn, unlearn, and relearn, because that is what will keep us moving forward and keep us, make us an expert in whatever field we are, not just in data science, but in whatever field we are. Okay, so with that, I would wrap the session. I think we are 3 minutes away, but here are my handles. Please feel to reach me out through different channels in whatever way is possible. We'll open it up for questions, and if there's no time restriction, we can take more questions. If there is, then please use these handles to reach me out for posting your questions.
Sure, ma'am.
Great. Thank you.
Ma'am,
Thank you for the opportunity.
Thank you, ma'am. Any questions, you can post it in chat box. If you have any questions.
And please share your feedback as well.
Sure, ma'am. Okay, ma'am. Ma'am, there is one question in chat box.
Yes, ma'am.
For web scraping, which one is the best, R or Python?
you can do it using both. So if, like I said, if you're looking at more flexibility, then Python is good, but it's up to your choice. There's no harm in using R as well, so not a problem. See, be very less concerned about the tool. Be more concerned about the output aspect. Once you're comfortable in one being very foundational, then you can do much more in others. So it shouldn't be a problem at all.
Okay, ma'am. Actually, one more question, ma'am. You asked about the book name and the author.
Okay, it is Homo Deus, Homodeus, Homo Deus by Yuval Harari. He also wrote another book, Homo Sapiens. That's also another book of Yuval Noah Harari, his name is. Any other questions?
I think that's all, ma'am.
Awesome.
So many told that is very useful, ma'am. Very informative, nice session. So many things they shared, ma'am.
I'm glad. Okay.
Okay, ma'am. Thank you, ma'am. Thank you. Thank you. I extend my heartfelt thanks to Kaushalya, ma'am, for her valuable speech in data science in a busy schedule. Actually, thank you, ma'am, for accepting my invitation in the first call itself. Thank you very much. So I would like to thank you, ma'am. I would like to thank our management, principal, and our dear HOD, ma'am, who constantly encouraged me in organizing this webinar. Thank you, HOD, ma'am. I would like to thank all the participants for your active participation throughout the session. Thank you all. Kindly fill the feedback link is available in chat box to get your e-certificates. Thank you, one and all.
Yeah, thank you, Kausalya ma'am, Kausalya NACHIAR ma'am. Thank you so much.
Thank you.
Participants, thank you all.
Thank you, everyone. Have a wonderful evening and please stay safe.
Thank you, ma'am.
So we are ending now. Kausalya ma'am, IT Kausalya ma'am, kindly share the feedback.
Yes, ma'am. I already shared, ma'am, in the chat box. Okay, ma'am.